Alrighty, so we have an hour. Any questions you have? Now's the time to ask.
What's the answer to number 4?
What's the answer to number 4? A, B, C, or D, depending on which your number 4 is.
I had to do it for tradition.
Nah, you're alright. You're alright. It's gonna be A. It's A for somebody. It's gonna be.
Can you talk about the ones where it was like on assignment A, where it was like make a balanced equation after, and it had like the triangle in the middle? I don't know how to do those ones.
Okay, so I'm not sure who asked that question, but who? Hudman. Yeah, no. Think about it, Hudman. Is it the one where it wanted is it the complete versus incomplete?
Yeah, it's the one you did the other day on the...
Okay, well, well, I know, but what I'm saying is no.
Okay, I get it.
Yeah, okay, just checking. Which, I'm going to be honest, I was shocked when I went through the test and realized that. Because that's stupid. You know what I mean? There's a lot of that. There were weren't there like 3 of them on that one homework assignment?
Yeah, there was.
And I'm like, why wouldn't you put not one of those on the test? I was baffled by that. Just baffled.
Yeah, I hate when we do that.
Yeah, well, me too. Try being the teacher. Is Buxton on here? Still no Buxton? How many people do we have?
75.
Because you guys know we're taking the test in an hour, right? I emailed every one of you and I emailed every one of your parents. So, hopefully. Okay? Now, one of you have a question.
Did you go over constitutional isomers?
Yeah. So it's funny, but that's the page I'm on in the book. All you need to understand is this. Is when they, let me get this. It's 4:15 today. 4:15. And this is Chem 11:10, chapter 12, pre-test review. So constitutional isomers. So what I've done, and there's a ton of them on the test, okay? The first thing you need to do is make sure they are not the exact same. And they might draw them backwards. You know what I'm saying? So be kind of careful. So if I looked at, let me see if I can find a question that I don't want to give it away, but let's see if I can find it. And I can't believe how many primary, secondary, tertiary questions there are. Alrighty, so which of the following? Okay, so here's an example. So let's say I did that. And it says, are the following constitutional isomers?
No.
No? Why not? Yeah, no, these are the same, because if I looked at it, all I would have to do is take this one and flip it, and it is the exact same thing. I would number this one left to right, I would number that one right to left. If I were to name it, they would be named the exact same thing. Does that make sense? So that's probably the first thing you need to watch out for, is make sure that, and that's a terrible saying, but yeah, make sure they're not the same thing. So if I were to give you, let's see, alright, let's say I did this. Let's say I gave you CH3, CH2, CH2OH, right? And CH3O, CH2, CH3. Are they constitutional isomers? Well, I would go and just count them up. So I've got 1, 2, 3. I got C3, right? And I've got H what? Oh, sorry. C3H what? H8 and then O, right? What do I got over here? Same thing, C3H8O. Now, here, my OH is on the end, right? Here, my O is somewhere in the middle, right? So would they be named the same thing? No, so would they be constitutional isomers? Yes. That's how I would do every problem. If you have to draw it, draw it. You know, go skeleton or something. But as long as I can look at that and say, clearly, that O and H are bonded to this C on the end. This O doesn't even have a what on it? What doesn't this O have with it? It doesn't have an H, so it can't be the same thing. Do you see what I'm saying? So that would make them constitutional isomers. That has to be the same. That has to be different. I don't know who asked that question, but does that make sense?
Yes.
Okay. Anybody else?
Can we go from the name to the structure?
Name to the structure, sure. So let's go with, let's say I went with 2 dash, now let me change that. Let's change this. Let's do this. Let's go 3 dash ethyl dash 4, 4 dash dimethyl dash 5 dash propyl nonane. Now let's make that decane. Let's make this decane. 5 dash propyl decane. Okay? So, if you recall what I did the other day, he remembers where I should start. I want to start drawing the backbone, and my backbone's got to have how many carbons in it? 10, which means I'm actually going to only have what? 9 lines. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now, because we always do things left to right, let's just say, for argument's sake, I wanted to go the other way. And let's name this, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say I went that way. Okay? Now, what's going to happen at 3? I'm going to have an ethyl. Now, what's an ethyl consist of?
2 carbons.
2 carbons, so I went 1, 2. Does that work?
Yeah.
Yeah. Okay, then I'm going to go where? 4, and I'm going to have a dimethyl, which means I'm going to have 2 separate lines, and I could do 1 up, 1 down. Sometimes they do this like that, right? That's my dimethyl, correct? And I'm going to go to my 5, and I'm going to draw a 3 lines, so I got 1, 2, 3. And that would be 3 ethyl dash 4, 4 dash dimethyl dash 5 dash propyl decane. That makes sense?
Yeah.
Okay? Anybody else?
Can you go the other way?
Yeah, you want me to give you a structure? Let's name it?
Yeah.
Alrighty, so let's say I wanted to name that. Okay? No matter what is this going to be when it's done? Who remembers what takes precedence here?
The cyclooctane.
This is going to be, no matter what, it's going to be a cyclooctane because of that 8-carbon ring, right? Now, where do I know I have to start numbering?
At the butyl.
At the butyl? Now, who said that?
Dodge.
Who? Dodge, okay. I would have probably went one step prior to that because we didn't know that it was a butyl yet. I would have just said, I know I'm going to start numbering at one of my branches, right? And then I would have said, well, let's name the branches so we know which one to make the one. And this one, obviously, he said is a butyl. This one is a what?
Ethyl.
This is an ethyl, right? So I know I'm going to go 1, 2, 3. Does it matter what the rest are? No, because I only need those two numbers, right? So who wants to read this, what it would be? Dodge, you seem to be jotting on the spot. What do you got for me?
1-butyl, -3-ethyl, cyclooctane.
Is he right? Yes, he is. Anybody else?
Can we go from like having like the formula like the CH3 to getting it to like a skeleton structure?
Yeah. So let me find a good one here. I want to find one with a couple of branches but not too many, so it can be fairly representative of what you're going to see on the test. There are a couple of these on the test. Alright, here we go. So, let's say I've got CH3 taken twice, CH2 taken 3 times, and a CH3 like that. Alright, so let's say I've got this. So, whenever I got something in parentheses like this on an end, I know I'm going to have some branches. Okay? So what I would do is I would start with this carbon right here. Okay? And I'm going to go carbon, and then that carbon is bonded to that H. Okay? And then it's bonded to these two. So I would have a line to another carbon with H's here, and a line to another carbon with H's there. And that's, those two are those two, right? That H is that H. Now, this 3 tells me I've got basically 3 CH2s in a row, right? Right? And then I've got one more CH3 like that, correct? Now, that is the what structure? Now, this was condensed. This is complete Lewis, right? Now, if I want to go skeletal, now I'm just going to go, I got a backbone here, so I got 1, 2, 3, 4, 5, 6. So I got 1, 2, 3, 4, 5, 6, right? And then I've got to have off my second carbon, I've got to have one more branch like that. So that goes from that to that, basically. So, Butler, was that your question?
Yeah.
I would say that I would probably, and granted I'm the teacher, never go straight from there to there. I just like to see it like this and then go to there, but, whatever. It's up to you. Does that make sense?
Yeah.
Yeah? Now, if it's any more complicated than that, they will draw it kind of branch for you. So what you'll see, let me kind of explain something here. Here was the example I did. Okay, I did this one right down here. If they are more complicated like this, see how they've drawn those branches in there where they go? That's what they're going to do. Does that make sense?
Yeah.
Because there's only so much you can do there. So just kind of, I don't know, just kind of plan on that.
Okay.
I mean, and they'll do, and if they get, like, I look at this one, they try to be really ugly here, but that's really not. This isn't that complicated. In fact, let's do that one. So I can kind of show you what they're trying to do here. Because all they're trying to do is screw you up. Okay? So this looks like this. I'm going to go... They've got a combination of condensed and Lewis here, but they go like this. They've got that, right? Now, here's the kicker, is they're going to ask you one of a couple of questions. One could be to draw the stick, or the skeletal structure here, or they could ask you to name it. There's a couple of different ways they could do this. Now, most of you, I think, are better at naming things from the stick figure, the skeleton, right? Anybody agree or disagree with that? Yeah? So what I would do is I would try to turn this into a stick figure by saying, how long is my backbone going to be here? Because this is an H, right? So I know I've got to start either here or up there, right? There's 6 carbons, right? So I got 1, 2, 3, 4, 5, 6. And what I did is I went like this. I started here and I went down, down, and I went there. And that gave me 6 carbons, right? I mean, that works, doesn't it?
Yeah.
So then, coming off of and this one branches first, that one doesn't branch till 3, this one branches at 2, right? Got 1, 2. So then I've got that right there, right? Correct? And then I've got 3, and then I've got a branch at 4, another just like that, right? And that's there? Correct? And I've got 5 and 6. So to number this, where am I going to number it from? Yeah, I'm going to go 1, 2, 3, 4, 5, 6. And if I wanted to name that, what would that be? Missing something here. 2, 4 dash dimethyl. Now, what did you say it was? Hexane. Is she right? Yeah, good job. Just like that. Okay. Anybody else? Up to 91, that's not bad. Anybody else? We still got like 40 minutes. I got nowhere to go.
head on 3x5?
I did. I did, actually.
You did?
I did, yeah. Yep, straight up something. And I spelled it freaking wrong. I just realized that.
I think you did.
I did, yeah. Wow, what an idiot. What? What?
You should put it in right now and make sure it's spelled right.
Yeah, you should go up and then make sure it's like spelled right and stuff.
Okay, so there's the front,
Just so like they can understand it, 'cause, like, you know.
and this is the back.
So
I'm a
alright.
dumbass.
What?
What? Was that Hudman?
Yeah.
Okay, so while we've got a brief flow here, I need an honest opinion of, if you're a senior, what you think about what happened yesterday.
I'm freaking upset.
Yeah, so I mean, I'm going to assume most of you know Mason, right? Mason hates school. He comes to school to do one thing, and that's to play sports, right? And the other day he's like, man, I can't wait to go back to school. I'm just like, wow, life has come full circle. But yeah, I mean, I'm going to be honest, I miss my students, which is kind of creepy, but you know what I'm saying.
You have a feeling?
Oh, who was that?
Yuri.
Now wait a minute. If I didn't like my kids, would some kids have my cell phone number? Would I FaceTime my kids? Would I make them a personal video and send it to them to answer their questions? I think not. So you might want to rethink that. Oh, I see how it is.
Can't see you, so I still have to give you shit.
Okay, so the other thing I was going to tell you is, so like, I've had a few kids, you know, send me emails and ask me questions, and I just made them like a personal little 5-minute video. I have a whiteboard at home, and I just turn my Chromebook and record it. But I also, I made McKenna like just a little video, like a little video on my phone, and just sent it right to her. So if you have questions outside of class, just shoot me an email. And if it's something I need to pencil and paper, I have a whiteboard at home, or I can just do it on my phone, whatever we got to do. You know, don't hesitate to ask me questions, especially now that we're coming up on the review, because I think that's going to be, you know, we got one test left after today. So, you know, we've got, 4 weeks, and we're going to hit it hard. So, back to today's test. Any other questions we want to look at, go over?
And could you go over what makes low boiling point and low melting point again?
Okay, so yeah, let me get the right pen. So, low, I think they focus mainly on low boiling point. Okay? Low boiling point. Okay? There's two things that are going to give it a low boiling point. Okay? Fewer number of C's, so fewer number of carbons as far as how many carbons are in it, right? Or more branching. Okay? The more branching it has, okay, now, somebody asked about this the other day, and when I talk about branching, what am I really kind of referring to? Does anybody remember this from the other day? More branching gives me lower what? Yeah, lower surface area. Didn't we talk about this the other day?
Yeah.
Was that kind of the same idea? So, the lower the lower my surface area, because and I want to say, is Taven here?
Yeah.
Okay, was it you and I that had this kind of conversation? Because I believe you asked me about how do I know which one takes precedence here?
Yeah, it was me and then it was Tiernan.
Okay, so they do, oh yeah, that's right, you and Tiernan. I don't believe that these questions overlap. Okay? what they're going to do is they're going to ask you a question about this, or they're going to ask you a question about that. Okay? They're not going to combine the two. Tiernan, are you here? No, Tiernan? Okay? Oh, you are?
Yeah.
Okay, so what they'll do is they're going to give you two straight chain hydrocarbons. One with 12, one with 7. The one with 7 is going to have a lower boiling point, because it has fewer carbons. And, I mean, that kind of goes in line, because if I have 7 in a straight chain, and I have 12 in a straight chain, the 12 has to have more surface area, because it's bigger, right? Okay? But when you talk about branching, they're going to have the same. So like if I did this, like if I was talking just this part, and I did, so 1, 2, 3, 4, 5, 6, 7, 8 versus this, and I did that, this one would be lower because it branches, it has less surface area than that one because it doesn't. Tolman, does that make sense? I believe that was your question, right?
Sorry, what?
Does this make sense?
Yeah.
That was your question, wasn't it?
Yep.
Okay.
Are they ever going to ask you about branches when it's like condensed formula?
A little bit, but they do a pretty good job of trying to show you like this. The only time they don't is when they do one like this. You know what I mean? But like I said, whenever they give me condensed, I would try to always go to here or to here, because I just think it helps us. I mean, let's face it, 90% of us are visual, right? So I would convert it into here or there, and I think it helps us see it better. Does that make sense?
Yeah.
So that's what I would do. I don't remember them doing that, but I guess they could. Okay? Was there a female voice there that was going to ask a question?
Yeah, with the boiling point and stuff, will they ever throw in like cyclic structures?
Ooh. I do not remember seeing that. I do not.
Okay.
But I would say cyclic would constitute lower surface area. Does that make sense? Because to me a cyclical structure is kind of like a branch structure, but I do not believe they overlap in that area. Okay?
Alright, yeah.
On the homework they asked like which compound was acyclic and which one was just cyclic. Are they gonna ask?
Yeah, so all you gotta know is if it's a ring, it's cyclic. It doesn't matter. No matter where it's at. No matter where it's at. I mean, if I do this and I do that, they're both propane, right? That's cyclopropane, that's just propane. Anytime it's got anything in it like this, it is technically a cyclic structure.
On the homework they just gave you the like condensed form of it.
Okay. Condensed form?
Like they just put like I don't even remember what it was. It's like C3H.
Okay, so that goes back to our little formula, remember?
Yeah.
CX H2X plus 2 versus CX H2X. This is cyclic, this is acyclic. And I know that because the two H's on the end are gone and they've been folded together. Now this could be cyclic or it could be a what? What else could this be? Does anybody remember? It could be what?
Straight chain?
Well, it could be, but
Chain.
if it is a straight chain, it would have to be a what?
Plant.
Nope.
Alkene.
Yeah, it'd have to be an alkene to be there. Does that make sense? So So it's cyclic or alkene is this formula, acyclic is that formula. That would be how you would tell there. Does that make sense?
Yeah, basically.
Okay. And these are what's called empirical formula, not condensed. That's what's called the empirical formula. What?
What if it's a branch alkane?
What do you mean?
If it's like...
Oh, if it's branched, it's still acyclic. To be cyclic, it has to have some kind of shape in it. You know what I mean?
Okay.
Yeah. No, it doesn't matter. Branched is still acyclic. Cyclic simply has to be a triangle, a square, a pentagon, a hexagon, you know what I'm saying? And then usually, I can't think of a condensed structure that is cyclic unless they draw the shape for you. You know what I mean? They're going to give you the shape. Okay? Good questions. Anybody else?
Can you go over the primary, secondary?
Yes. So, let's say I did, where's that? This is a good one. Okay, so let's say I did this right here. Let's say I wanted to do this one, and I wanted to go, let's look at this one. Okay, look at this carbon right here, and let's say, is it primary, secondary, tertiary, or quaternary? 1 degree, 2 degree, 3 degree, or 4 degree? Three degree. Who said that? Who? Hudman. Why is it a 3 degree? That 1 carbon, 2 carbon, 3 carbon, right? What about this one? It's 2 degree because it's bonded to 1, 2 carbons. What about this carbon? 1, 2, 3, 3 degree. What about this carbon? It's 1 degree. Now, if it's like this, I think it's way easier. You know? If I look at carbon 4 here, it's a 3. All I got to do is count the what? Yeah, how many lines? 1, 2, 3 lines. What about this one? You know, it's 2. What about this one? 2. What about that one? 1. You know what I'm saying? When it's skeleton, I think it's way easier. And I'm telling you, it shocks me how many of them are on the test.
Thank you.
Yep.
Does the ring have more surface area?
I would say yes. Like I said, I don't remember that kind of question overlapping, but I would say a ring would have less surface area than a straight chain.
So it'll have a lower boiling point?
Yes. Yeah. I don't remember that being addressed ever when we talked in that section. You know what? Give me 1 second and let me look. But I do not remember. Yeah, they do not. Yeah, I'm looking in the book right now, and I do not see. So when they talk, there's not a question where they combined a ring in the boiling point questions. So yeah, I don't think you'll run into that. Just know the part I put down, straight chain versus branch chain. Okay? Are we all good with the alkyl halides, the halogenation stuff we talked about last time? Where I add a fluorine, a bromine, a chlorine. What?
Can you just go through it a little bit?
Yeah, so like if I did this, and I added Br2 to that, okay, I know that every one of these have H's on them, right? Every corner has an H on it. Okay? And all that's going to happen is this bromine is going to split up. I got Br like this. It's going to split up. One of them is going to go here. That is going to go there. What you're going to end up with is this. This now is called an alkyl halide because it has been halogenated. This whole thing is called halogenation because I'm adding a halogen, right? And this is called an alkyl halide now, and then that would just be, hydrogen bromide or whatever. Okay?
And I don't know what the bromine goes.
It can go anywhere. It can go to any one of those H's. One of the bromines is going to replace one of the H's. That H is going to go bond with that bromine. They both don't go there, just one of them. Does that make sense?
Yeah, thank you.
Yes, sir.
And it only replaces an H. That's all it can replace. It's basically like single replacement where that bromine and that H just trade places. Does that make sense? You kind of remember the old single replacement reactions? Actually, I guess that'd be double replacement because my H and my Br are trading, both of them are trading places, right? So, kind of like that. Sierra, does that answer your question? I think that was you.
Yeah, it does, thank you.
Okay. Anybody else? Can anybody else hear that clicking sound? Whatever it was, they stopped, I guess. Anybody else?
I have a question about the review 2 days ago.
Yeah.
So sometimes some of the problems you say like, is this, you give the name, say if it's like valid or it exists or not, and I don't remember how to figure that out.
So, there are a couple of questions, and what they do, let me find an example so I can explain it, because it's hard to just explain without looking at something. So, okay, so here's an example. So if I said 1,5 dash dimethyl cyclohexane, and I would say, is that a valid name for something? Okay, so what I would do is I would draw that. I would say, okay, well, where am I going to start? Well, I know I'm going to start with cyclohexane, right? So I'm going to go like that, right? Hello?
Yeah.
Yeah.
Right.
Then I'm going to go 1, 5. So I'm going to go 1, 2, 3, 4, 5. And it's dimethyl, so I'd go there and I'd go there, right? And then I would say to myself, self, is that valid? So my question to you is that a valid name for that compound?
No, because you're extending the effect over there.
Say that again?
No, because in the backbone? Because you ain't connected like in a. Because you went to only 5, you didn't go to 6. You know.
Okay, but I could go to 6. But do I need that 6?
Not on purpose or not? So then it would be valid.
Is that you, Tiernan?
Yes.
Okay, so Tiernan has it. It's not valid. The answer to this is no. Because whenever I'm using a cyclo, I start on a branch and I go immediately to the next branch. Well, that next branch, if I go the other way, would be 1, 2, 3, which would give me 1,3 dash dimethyl cyclohexane. And this is a lower sum than that one. Remember, we always want to have the lowest sum possible. Does that make sense?
Yeah.
Who asked this original question? It was a female voice.
LaRose.
Who?
LaRose.
Oh, LaRose. Does that make sense?
Yeah.
Is your brother on here?
Yeah.
Okay. Hey, Bo. Anybody else? Or should we do another one?
Yeah.
Do another one?
Yeah, that'd be great.
Okay. So, let's say I went... here we go. So, they give us 1,3 dash dimethylpentane. Okay? 1,3 dash dimethylpentane. So, where am I going to start? Start with my pentanes. I got 1, 2, 3, 4, 5. Okay? And then if I number them 1, 2, 3, 4, 5, off of my 1, I've got to make a methyl, right? So off my 1 I make a methyl, and then off of my 3 I make a methyl, right? So is that correct?
No.
No, why?
Because you changed the backbone with the
Yeah.
methyl on number 1.
Exactly, right? So if I have a straight chain, is there anything I could say right now about it that I could make as a rule for us?
You can't have something on the first.
Yeah, I'll never have a 1. If it's a straight chain and it's got a 1 in it, it is wrong. Now, if it's cyclo, it's not, but if it's a straight chain and it's got a 1 in it, it will be wrong every time. So what would that be if I did it correctly?
It would be just 3-methyl hexane.
3-methylhexane now? Now, what did you have to do there?
Or no, it would be 4. It would be 4, sorry. Or no, because you would start from the other side.
Ah, exactly. I'd have to number it this way, right?
Yeah.
Because that does make it 3 instead of the other way makes it 4, so now it would be 3-methylhexane. That's a good point. I don't know who that was, but...
That's Heimbach.
Oh, Heimbach, good job. Allison, was that you?
Yeah.
I don't know. There's probably only three of those. But if you draw them out, I think it helps you see it.
Okay.
That's what I always do. I'm 100% a visual learner, which is why I teach that way. So.
Can I ask you a question about the final?
Yeah. I haven't looked at it. I don't know. I haven't looked at it. Last year I had 50.
Okay.
But I'm going to be honest, I haven't looked at it this year yet. Try to take it 1 unit at a time. I just started prepping on chapter 13 yesterday. So.
Okay.
Okay. I will look, though, when this test is over, And on Monday I'll let you know. Or not Monday, on Friday I'll let you know. Okay? Anybody else?
Bryce thinks that you're the best teacher.
Who?
Bryce.
I appreciate that. I try really hard. In case you didn't hear, I will be here next year.
You're staying?
Yep. Well, they didn't have anybody retire. So they ended up, they moved one person, so it put one opening at the place on the hill, and apparently they didn't feel I was a good fit for that. Can't imagine why. So that's why I was asking for Buxton.
If you had the choice to go to the school on the hill, would you?
I'm going to be honest, at this point, all my kids have graduated. It is what it is, you know. But I'm not heartbroken by any means. I mean, I love teaching, don't get me wrong. I love to teach. I just, you know, my next step in my life, I think, is to become I want to be a principal because I want to open a new school when they build it. That's my goal. So, got to start somewhere. But, you know, I love teaching, don't get me wrong. I would like to think that shows. I mean, I would like to think that if someone ran into you and they asked you if you have a teacher that you feel loves teaching, I would like to think that you would have thought of me. You know what I'm saying? So, I mean, I love what I do. That's it? We ready to rock and roll? Okay,
Let's do it.
we have 12 minutes. I will open that test in 12 minutes. Oh, wait. When I do open it, the password is... Let me remember, I forgot to write it down. Okay, when I open it, the password is right here. So we got 11 minutes. Organic flowers, all one word. Okay? So I'm going to cut my recording off.